So let's take a look at Pepzone here and look at a replenishment amount based on our past performance. And what we have found out is that our average lead time, our average demand is 15 gallons with a standard deviation of 6. And we're going to order when we're at 20 because we want to make sure that we have a little bit of a cushion. We don't always want to order exactly at 15 because we're afraid that, you know, basically there'll be a lot of times where we actually have a stock out. Now let's look at the whiteboard and think about this for a second. So if the average demand is 15 and we want to make sure that we never have a stock out, then we don't want to order just so that we have enough for 15. Because then that means that 50% of the time demand will exceed 15, and then 50% of the time it will not exceed. So we want to have a little bit of a buffer. The buffer that we have decided on is 20. Now where is 20 in relation to that? All we really know at this point is it's to the right of our 15 because it's greater than. And so what we're looking for is the probability of a stock out now is going to be that area right here. So this is what we want to figure out. So to do that, we have to come up with a z-score at 20 and calculate a probability that corresponds to that. So what is the z-score at this point? And then what's its corresponding probability? So to come up with a z-score, again, it's the number of standard deviations away from the mean. And in this case, we're talking about x minus mu over standard deviation. That would be 20 because that's our value of x. We determined that, that stock out amount minus the mean divided by standard deviation gives us a z-score of 0.83. So that 0.83 then corresponds to a probability. And we have tables that can give this to us. We can also use Excel to find that information. So at 20 is a z-score of 0.83. Now we want to know that probability here. So let's see if we got our numbers correct. There we go. 20 minus 15 divided by 6 gives us 8. And now we need to find the area that corresponds to 0.83. And if we look it up in the table that's in your book, now I want you to make sure you have this, make sure you can find it in your ebook, you will see that you have a table that goes down to 0.8 on the left side, and then you go over to the 0.03 column, and that is how you find a probability that corresponds to 0.8, which is over here, and then the 3, which is the column for that. Now, what does that tell you? That tells you the probability of being less than. Your table is always based on being less than. So in this case, with a standard a z-score of 0.83, from this point to the left is 0.7967. So the probability of being 20% or less is 0.7967. But is that what we were looking for? Who knows or who remembers how to come up with complement? So we know the probability of being 20 or less. What about 20 or more? Or actually more than 20. We have to take the complement of that, which means this area then is 1 minus 0.7967, or as you see up on the screen there, 20.33%. So the probability of a stock out right now, if we always have enough for about 20 on average, is 20.33%. Do we want to run out of stock basically every 5th day, which is 20%? If the answer is no, then we need to change that amount. Okay, so right now this is what you have, and always think of this as pieces of a puzzle. For example, if you know that that's 0.7967, that's one piece. The other piece would then make it 100%. That's why you have the complement. You can also know that from the mean out to that 0.83 is also, you should know that amount as well. And let's see here, let's get a different color. We know that from 0 to negative infinity is 0.5. Don't you love writing with a mouse? Which means this area here is going to be 0.7967 minus 0.5. Whew, that was hard. Because it's, again, two pieces of a puzzle. If you break off 0.5 of 0.7967, that leaves you 0.2967. And I'm not going to write it to save everybody from seeing my terrible handwriting. So always think of this as definitely pieces of a puzzle. And with that, you can come up with pretty much anything. I want to know the probability of 12 on this side. I can find the probability of less than or greater than. I can find out the probability between 12 and 20 if I want, all based on that. But let's look at it a little bit differently. Take the exact same example. And what we'll do here is instead try to find the right stock out amount so that no more than 5% of the time we run out. Okay? Now we can never be 100% because what would we have to have on hand so that we never run out? Well, it would be, we'd have to be Amazon to make that happen, right? We'd have to have such a huge inventory to make sure that we never ran out. So we are allowed to have a little bit of cushion. So basically 1 out of 20 days, if we ran out, okay, that's fine. We've all been to Starbucks, gotten in and said, hey, I want a cinnamon dolce latte. And they say, sorry, we're out of blank. Okay, doesn't happen often, but if it happens 1 out of 20 days, I guess it's to live with. Hopefully it's even less than that because, trust me, my wife loves her cinnamon dolce lattes. So we can see that, but there's going to be cases where they run out of stock because they just have only a certain store size, right? All right, so how do we find that? Again, we still know that 15 is here. What we don't know is the value of x that corresponds to that. So what we need to do is take this, put in our 15 here, put in our 6, not our standard deviation, and we're trying to find x. But can we find z if we know this? And that's where we can do using Excel, or we can use a table to do that. We can come up with the z-score at this point based on an area from here over. All of this area is 0.950, right? Because if that's 0.05, the rest of the area must be 0.95. So if I can find the probability that corresponds to 0.95 and the z-score then, that's called norm inverse. Or you can look at the table here and see that it is 0.95 is between 1.64 and 1.65. Make sure you can see that. And so we can use 1.645 for our z-score here. So in this case, I can do 1.645 because that would be the z-score at this point. Okay, make sure you can see how that works. And when you do all of the math, you would get x equaling 24.87. And of course, we want to round up so that I'd rather only run out 0.48% of the time as opposed to more than that. And so we can just say approximately 25. So that becomes our new ordering level in this case. And so an example of taking a value of x and finding the probability, and then this being the probability and finding a value of x. And as you can see here, here's your when you do not run out, and then here's when you would, because obviously your amount that you need will vary more and less than 15. So that's solving then for that. Instead of ordering for 20, we'll order 25. Of course, that means a little bit higher inventory levels, but that also means we've reduced the number of times percentage that we run out of stock by 15%, which hopefully will then improve the bottom line anyways, and it's okay if our inventory levels go up a little bit. We can use norm dist to find the probability using a value of x, and we can use norm inverse to find a given value knowing the probability. And you can see that we put those values in here. And so if I put in for norm dist, now this isn't norm.s.dist, this is norm dist. We put in the 20, the 15, and the 6, and it will give us the correct percentage. If I put in the percentage with the mean and the standard deviation, it will give us the correct answers as you see here. So the only way to get good at this stuff is to practice it. That's why you have homework. That's why you have examples. Go through those, see how all of that works together, and then that will help you figure out everything you need to know for Chapter 6. Chapter 6 is really about normal distribution and z-scores. And if you can do that, you will do just fine for the next couple of chapters here. But don't rush it. Understand what you're doing here. Make sure that you go back and reinforce this through all of the different materials to make sure that you understand why the bell curve is your friend.